Convective currents. Sea breezes happen when cooler, denser air moves from the water onto the land. As this air moves inland, it heats up from the warmer ground and starts to rise. The rising air is then pushed back over the water, where it cools down and sinks, starting the cycle all over again. Thermals, which are rising columns of warm air, form as a result of solar heating. Fronts. A front is the boundary where two different air masses meet, often one with higher pressure and the other with lower pressure. Whenever you fly across a front, you'll notice a change in wind. But one of the most noticeable changes is the shift in temperature as you pass from one air mass to another. Thunderstorms. Thunderstorms go through three distinct stages in their life cycle: cumulus stage, mature stage, and dissipating stage. Cumulus stage, this is the building phase, where continuous updrafts are present as the storm begins to form. Mature stage, this is the most intense phase, where both updrafts and downdrafts occur. Severe wind shear and turbulence are common during this stage. The storm reaches the mature stage when rain begins to fall. As the precipitation falls, it drags air downward, creating a strong downdraft. This downdraft spreads out across the surface, often moving well ahead of the storm as a mass of cool, gusty air. Dissipating stage. In this final stage, the storm is mainly producing downdrafts as it rains itself out. Thunderstorms are produced by cumulonimbus clouds, which form under specific conditions. There must be enough water vapor. The atmosphere needs to have an unstable lapse rate. There must be an initial upward push to start the process. A key feature of thunderstorms is lightning, which always accompanies them, as it's lightning that creates thunder. Lightning is most likely to strike when the outside air temperature, OT, is between -5 degrees Celsius and +5 degrees Celsius. Wind shear turbulence is one of the most dangerous hazards thunderstorms create. This invisible phenomenon can be particularly risky for aircraft during takeoff and landing. Thunderstorms always come with adverse winds, and these winds can be found many miles away from where it's raining. These winds can include crosswinds, gusts, or sudden shifts, which are especially dangerous during takeoff, approach, and landing. Wind shear can also be present near the ground during strong temperature inversions. It's important to avoid flying under the anvil of a thunderstorm. Even though it might look clear, there's still a risk of severe turbulence and hail. The most severe thunderstorms, which might include heavy hail, destructive winds, or even tornadoes, are usually associated with squall-line thunderstorms. A squall line is a narrow band of thunderstorms that typically forms ahead of a cold front. Pilots should always be prepared for the possibility of hail with any thunderstorm, especially near the anvil of a large cumulonimbus cloud. Embedded thunderstorms are especially dangerous because they're hidden within layers of clouds, making them hard to see. If you do find yourself in a thunderstorm, follow these guidelines. Fly straight ahead. Set your power for the recommended turbulence penetration airspeed. Maintain a level attitude. And remember, never fly under the anvil of a thunderstorm. Even though it might seem safe, severe turbulence and hail can still be present. When avoiding thunderstorms, especially those identified as severe or showing intense radar echoes, it's recommended to circumnavigate the storm by at least 20 nautical miles. Finally, it's important to understand the difference between a squall line and a squall. A squall is defined as a sudden increase in wind speed of at least 16 knots, with the wind rising to 22 knots or more and lasting for at least 1 minute. Keep in mind that airborne weather avoidance radar detects precipitation, but does not detect small cloud droplets, like those in clouds or fog. This means that while radar can help you avoid rain, it won't necessarily help you avoid instrument weather conditions.